Hello everyone, welcome to my channel. So I've started offering specialized one-on-one classes in physics, chemistry and math EE for both SL and HL. So for the rates, the standard rate is $35 per hour. If you book like 5 or more classes, it'll be 30, and if you book 10 or more, it'll be 25. So these courses will be tailored to your needs. Whatever you want to learn, we can discuss in these classes. Please don't hesitate to reach out to me. You can contact me at this given email, and yeah, to schedule your class. So with this, let's get started with this paper. Thank you.
Hello everyone, welcome back to my channel. Today we'll be solving one of the Chemistry SL Paper 2 of May 2025 attempt. And let's get started with the first question. So phenolphthalein is an acid-base indicator. This is the structure of phenolphthalein. Right? You have to determine the molecular and empirical formula. So for molecular formula, we have to exactly count the number of carbon, hydrogen, and oxygen atoms. If I start counting from here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13, 14, 15, 16, 17, 18, 19, 20. There are 20 carbon atoms, so starting with C20. Next, the number of hydrogens. Three bonds, so one hydrogen here. No, wait. One, two, three, four. Four hydrogens here. Then one, two, three, four. Another four here. One, two, three, four. Another four. So 12 hydrogens till now. This one is 13 and this one is 14. A total of 14 hydrogen atoms. And then oxygen, 1, 2, 3, 4. The C20H14O4 is the molecular formula. Empirical formula is basically the simplest whole number ratio of the molecular formula. So 20 is to 14 is to 4. This will become, like if I divide everything with 2, I'll get 10, 7, 2, which cannot be simplified further. So empirical formula is C10H7O2. Fine. Next, this is phenol. So we have to state an equation of phenol when it starts acting like an acid. So basically, this hydrogen in the OH can dissociate. The phenol has a molecular formula of C6H5OH equals, it will react with water when it acts as an acid. You will get C6H5O minus ion and then H3O plus equals. To the next question. So models are useful for explaining characteristics and predicting outcomes. State and explain two properties of liquid using kinetic molecular theory model. The first one would be liquids have a definite volume. Okay, so liquids always have a fixed volume. Why? Because the particles are close together and they cannot be easily compressed. The other property is liquids can flow. Yeah. Why can liquids flow? Because the particles can move past each other freely. Done. These are the two properties of a liquid using the kinetic molecular theory model. Now the next question, ammonia. Ammonia is produced industrially using this reversible reaction, also called the Haber's process. Now we have to find the equilibrium constant. Moles of nitrogen, hydrogen, and NH3 is given, and the volume of reactor is also given. So we'll find the concentration. Concentration of N2 would be 30 divided by 55, 0.545. Concentration of H2 would be 40 divided by 55, which is 0.727. And concentration of NH3 would be 6.17 divided by 55. It's 0.112. And the equilibrium constant key would be N is 3, product squared divided by N2 H2 whole cubed. Now I'll just plug in the value 0.112 whole squared divided by 0.545 times 0.727 whole cubed. Now if you put it in a calculator, you'll get 0.0599, which would be the final answer of this question. Now next, the volume of reaction container of the mixture at equilibrium is suddenly decreased. So we are decreasing volume or increasing the pressure. Here's the graph of concentration of nitrogen versus time until it reaches the new equilibrium. A decrease in volume will basically increase the pressure. Now, by La-Chatelier's principle, if you increase pressure, reaction will shift to the side with less moles of gas to decrease the pressure, basically. So it'll shift to the product side because on the reactant side, you have 4 moles of gas, or on the product side, you have 2. And so the reaction shifts, or the equilibrium shifts to the right, and as a result, concentration of nitrogen will decrease from the current equilibrium position. So decrease the pressure, equilibrium shifts to the right. So the concentration of nitrogen will decrease. Yeah, probably maybe this is your new concentration. Yeah, kind of how it looks like, or we can maybe draw it a little bit better. Like this. Done. Now the next one. Halogenoalkanes are used as refrigerants and solvents. So we need to find the name of this ion of this substance X, which is CH3CHBr whole thrice. So if I draw the structure, it looks like this. Now to name this, we can either number it from the left or number it from the right. In this structure, there are no functional groups, there are only substituents. So methyl CH3 and Br. So two types of substituents are present. So we have to use the lowest locant rule. So if I number it from the left, I'll get this. So the positions are 2, 3, 3 if I start numbering it from the left. And if I number it from the right, I'll get 1, 2, 3, 4. The numbering from right will give me 2, 2, 3. So if I apply the lowest locant rule, the first one is the same number, cancel it out. Between 3 and 2, 2 is the lower number. Yeah. As a result, we'll choose the second set of ordering, that is from right to left. The first one would not be correct. So I'll just remove it. And so now to write the name, we'll basically we'll write the substituents in alphabetical order. So it's 3-bromo, then 2,2-dimethyl. Main chain is 4 carbons, so bute, all single bonds in. 3-bromo 2,2-dimethyl-butane. That's the IUPAC name of this structure. Next is we have to find the percentage mass of hydrogen in substance X to 4 significant figures. So we'll find the molar mass, which is 6 times 12 plus 13 times 1 plus 79.9. Gives you 164.9. Mass of hydrogen would be 13 times 1 because you have 13 hydrogen atoms in total, which is 13. The percentage mass of hydrogen. This will be the mass of hydrogen divided by total mass times 100. So if I feed it in a calculator, I'll get 7.884%. Because it clearly said up to 4 significant figures. Next, we have to draw a structural isomer of molecule X. For structural isomer, maybe like we can just shift the CH3 on this carbon. You'll get an isomer. Yes. CH3, CBr, CH3, CH3, and CH3, CH3. Isomer of molecule X. Next, the substance X undergoes nucleophilic substitution with a hydroxide nucleophile. Use the movement of electron pairs during the reaction using curly arrows. So you just have to show the reaction using curly arrows. So this is the compound. Now what happens is this bromine is more electronegative than carbon. So bromine will have a delta negative charge and carbon will have a delta positive charge. Now OH, which is the nucleophile, it will attack the positive center and the carbon bromine bond will break. Right, so electrons, the lone pair from oxygen will form a bond with this carbon, and the bond between carbon bromine will break, and bromine will take both the electron with itself. As a result, finally, this will be your product. And this will have a Br minus sign. Done. Now, we need to contrast homolytic and heterolytic fission. So in a homolytic fission, basically your covalent bond will break evenly and each atom will take one electron. And at the end, you'll get two free radicals. But in heterolytic fission, basically the covalent bond breaks unequally. One atom will get both the electrons and the other atom will get nothing. So in this case, ions will be formed. One will be a positive ion or a cation. The other one would be a negative ion or an anion. Just write it out. Mm, And each atom takes one electron, forming two free radicals. For heterolytic fission, breaks unequally or unevenly, and one atom, a more electronegative atom, takes both electrons, forming a cation and an anion. Done. Next, using collision theory, we have to explain how increase in temperature increases the reaction rate. Going point-wise, the first point is basically when we increase temperature, the particles will have like the kinetic energy of particles or gas particles will increase. There's particles, more kinetic energy. As a result, more particles will have energy greater than the activation energy. So more successful collisions will occur per second. Apart from this, the number of collisions will also increase because the particles are also moving faster, which is a minor achieve. I mean, that's a minor effect, but still, you can write this. the number of collisions will increase as the particles will start moving faster. And because of these two reasons, the rate of reaction increases. Next one, we have ethyne, C2H2, which is hydrogenated to form ethane. So 1 centimeter cube of ethane is reacted with 160 centimeter cube of hydrogen in a container at 420 kelvins and pressure. Ethane is the only product. Determine the maximum possible volume of ethane under the conditions of temperature and pressure. Now, if in a reaction, all the reactants and products are gaseous, we can use the volume ratio instead of the molar ratio. So here we'll use the volume ratio to first find the limiting reactant. Okay, this step is to identify the limiting reactant. What we'll do is we'll find volume by stoichiometry coefficient for both C2H2 and H2. For C2H2, volume is 140, stoichiometry coefficient is 1. 140 over 1 is 140. Similarly, V by SC for H2, which is your other reactant. This will be 160, which is the volume of hydrogen, 2, which is the stoichiometry coefficient. 160 over 2 is 80. Now, the one which is smaller is the limiting reactant. So from here, I can say H2 is the limiting reactant. Done. Now, using the volume of H2, we have to find how much C2H6 or ethane will be produced. So we can write a volume ratio, volume of C2H6 produced by volume of H2 reacted. This will be 1:2 ratio, right? So H6 produced, volume of H2 reacted is 160 because H2 is a limiting reactant, so all of hydrogen will react. From here, we can just find volume of C2H6 produced, which is 160 over 2, gives you 80. So 80 centimeter cube of ethane will be formed. I mean, there's a maximum possible volume of ethane that will be formed. Now, next is we have to determine the total volume of gas present in the container at the end of reaction. So volume of ethane, C2H6, this will be 80. Volume of H2 will be 0 because all of hydrogen will get used up. Now, we have to identify how much ethane will react and how much ethane will be left behind. For that, again, we have to write a stoichiometric ratio between ethane and hydrogen. Volume of C2H2 reacted, volume of H2 reacted. C2H2 coefficient is 1, H2 is 2, so it's again 1:2 ratio. C2H2 reacted. Volume of H2 reacted is 160, giving you 1/2. (160 over 2), which is 80 centimeter cube. So out of initial 140 centimeter cube of ethane, 80 centimeter cube will react. So the rest will be left unreacted. So C2H2 left. This will be initial volume minus the amount reacted is 60 centimeter cube. So total volume of gas at the end of the reaction, this will be 80 centimeter cube of C2H6, 0 for hydrogen, 60 for ethane, C2H2. So 80 plus 60 giving you 140 centimeter cube. Now the next question. We have a lithium-ion battery which consists of lithium ions from on lithium graphite. Fine. So part A says that lithium ions are produced at the cathode from lithium atoms embedded in graphite. Let us state a half equation for the reaction occurring at anode during the discharge. So lithium solid basically will lose an electron to form lithium aqueous and it will release an electron. This is the half reaction at anode. And it also goes with the fact that at anode anything is oxidized and cathode there is reduction. The next part, lithium-ion battery is rechargeable. Annotate the diagram below to show direction of flow of electrons. Okay, fine. So generally, when the battery is running, electrons are generated at the anode. So you can see that lithium is generating electrons here. So electrons will flow from anode to cathode generally when the battery is working. During charging or recharging, what happens is electrons are flowed in the opposite direction. So instead of electrons moving from anode to cathode, electrons will now move from cathode to anode. This will be the flow of electrons. Now, suggest why solar panels are often connected in parallel with lithium-ion batteries. Basically, if we use solar panels, we can get the electricity, we can get a continuous supply, power supply. And this power, which is solar power, which is technically free, can be used to recharge these batteries. So this is done to provide a continuous power supply. The battery using solar power. Now the last question, sulfur dioxide, SO2. SO2 is involved in formation of acid rain. We have to first write the electronic configuration of sulfur. Sulfur has 16 electrons. Electronic configuration will be 1s2, 2s2, 2p6, 3s2, 3p4. Next is the Lewis structure for SO2. So I'll do the calculations on the right. Number of valence electrons. Sulfur has 6 valence electrons and 2 oxygens will also have 6 valence electrons each. Total of 18. Then we'll find number of valence electron pairs, which is 18 divided by 2, 9. So there are a total of 9 electron pairs. Now we have this bank. So first we'll draw sulfur, we'll draw 2 oxygen atoms. We have to connect them together. So we'll use up one electron pair. So 9 minus 2, you're left with 7 electron pairs. With these 7 electrons, you'll first fill the octet of the oxygen atoms outside. 1, 2, 3, 3, 6 electron pairs are gone. The last electron pairs can be placed on sulfur because sulfur's octet is not complete. Done. Calculations are all done. Now, if you check, sulfur's octet is not complete yet. So sulfur has 6 electrons in the outer shell. So one of the oxygen atoms will lose and basically share a pair of electrons with the sulfur. Another information is sulfur belongs to period 3, and any element in period 3 can expand their octet. And, and so as sulfur can expand the octet, another oxygen will form a double bond with this sulfur. So this becomes the Lewis formula or Lewis structure of SO2. Next, we need to deduce the electron geometry and molecular geometry of sulfur. Around the sulfur atom, we have basically 3 lone pairs, 2 bond pairs and 3 electron pairs around sulfur, right? Out of which 2 bond pairs and 1 lone pair. So if you have 3 electron pairs around a central atom, the electron geometry becomes trigonal planar. And if you have trigonal planar with 2 bond pairs and 1 lone pair, because of the bond pair, lone pair bond pair repulsion, what happens is the structure gets bent. And hence the molecular domain geometry would be bent. Now, to explain the polarity of SO2, right, first thing is SO2 is a bent molecule. due to the presence of lone pair on sulfur atom. Now what happens is the two SO bonds are polar. Yeah. But because of the bend shape and because of the presence of the lone pair on sulfur, the polarities do not cancel out. And because of that, SO2 is a polar molecule. Cancel out the polarity of the lone pair. Hence, molecule has a net dipole moment and is polar overall. Now, sulfur dioxide. Sulfur dioxide reacts with rainwater and oxygen to form sulfuric acid. We have to give an equation with state symbols. So, SO2 gas plus O2 gas plus H2O liquid gives you H2SO4. To balance this, we just have to put a half in front of oxygen. Or if we multiply everything with 2, we should get 2, 2, 2. And this becomes your balanced chemical reaction. Now next, we have to explain with reference to the oxidation state why this is a redox reaction. Sulfur in SO2 would be plus 4, yeah. In SO2, if you take sulfur as X, X plus 2 times minus 2 equals 0, gives you X equals plus 4. And in H2SO4 is plus 6. Why is it plus 6 for H2SO4? If you take H2SO4, take sulfur as X, hydrogen is 2 times plus 1, sulfur is X, oxygen is 4 times negative 2, and dash sum is 0. So X minus 6 is 0. From here, we get X as plus 6. And next, we have to check the oxidation number of oxygen. This will be 0. Okay. And in H2SO4, oxidation number of oxygen is minus 2. The sulfur gets oxidized while oxygen gets reduced. Sulfur gets oxidized while oxygen gets reduced. Sorry. Hence, this is a redox reaction. Now, the last question. Describe the effect of acid rain on buildings that are made of limestone, and including, we have to include a chemical equation. Okay, so acid rain reacts with calcium carbonate in limestone, will cause the stone to dissolve and erode. The reaction will look like this: calcium carbonate solid, this H2SO4 equals, giving you CaSO4 equals plus CO2 gas plus H2O liquid. Now with this question, we are done with this paper, but actually 9 marks is missing from the end of this paper. So the full paper and the official mark scheme are yet to be released, so we'll have to wait for that now. As soon as the full paper is released, I'll solve the rest of this and I'll also upload it. Thank you so much for watching and all the best. Bye bye. Bye bye.